one of our signal splitter device. So what we made some setups here. We have here a signal source simulator, which is 0 to 10 volts equivalent. We have our signal splitter, single input. We set this one for 0 to 10 VDC input. And we have here output number 1, we set it for 4 to 20 milliamps output. And output number 2, we set that one for 0 to 10 VDC output. So basically, the function of this unit is to just split the signal. Single input, 0 to 10 VDC, and then split the signal. First output, you can choose 4 to 20 milliamps, and second output, you can choose 0 to 10 VDC. So as you can see right now, if I start to simulate the voltage, let's say I inject here 1 volt, so our meter will respond accordingly. So we have here the second output, output number 2. Output number 2 is set to 0 to 10 VDC output, so you'll get here 0.99 volts, which is almost equivalent to 1. While the first output, as we configured it for 4 to 20 milliamps, is getting us here 5 milliampere, which is almost equivalent to 1 volts input signal. So if I start to increase until 2 volts, you will notice that the value is also increasing from our outputs. 3 volts, increasing, 4 volts, and here is the 5 volts. So we can see our output modules or output devices are responding accordingly. So meaning this device is giving us the correct signal. 6 until I reach 12. When I reach 12, we should expect half of when it reach 10, we should expect half of the output. When we reach 10, this is full 100%. So we got here a 20 milliampere output, and we got here also 9.92 volts, which is almost the same. So if I make it half, like 5, we got here a 12 milliampere, which is half of the 4 to 20 milliamps, and we have here almost 5 VDC, same as the signal source simulator. So again, yeah, this is working properly. So what we did from this device itself, in the input, we set that one for 0 to 10 VDC input. Your input voltage should be terminal N should be plus signal, terminal P should be minus signal, operating power Q should be plus 24 VDC, and then R should be minus, this is 0 VDC. And then on the output, very important, we are using here active output, since we are connecting directly to the meter. So active output I should be plus. Okay, connected it high. You can see from here there is a letter designation. So I should be connected to the plus, and then you can see from here again L should be connected to the minus. This is output number 1, set as 4 to 20 milliamps. Output number 2 is set as 0 to 10 VDC. We can see from here that we are connecting for 0 to 10 VDC. You should see this diagram here. F is plus connected to the multimeter, plus. We can also see that F letter is from here, and then H letter is here. We are connecting to the minus, to the multimeter. So, and then in the configuration, if you want to review the configuration one more time, well, let's see. So system is okay. We're just going to open up this cover. We can see from here that switch number 1 stands for input. Switch number 1 stands for input. So input is switch number 1. We set that one as a 0 to 10 VDC output. You can see that my dip switch configuration is second dip switch is only on. 0 to 10 VDC, second switch is only on. And then for the output, you can see here switch number 2 stands for output 1. So output 1, we set that one at 4 to 20 milliamps. We followed this configuration. Pin number 1 is on, off, on, off. So we can say on, off, on, off. This is 4 to 20 milliamps configuration. Switch number 2 stands for output number 1. Switch number 3 it stands for output number 2. So we set that one for the 0 to 10 VDC, which is the connected multimeter here. So 0 to 10 VDC, only switch number 2 is turned on. You can see here, turn on. So yeah, so this device is designed for this purpose, and it should be working accordingly if the configurations and the connections is properly connected. So that's all. Thank you.